This is WFNP 88.7 Rosendale. Welcome to Curiosities of the Cosmos. I'm your host, Allyson Sheneman. Today I've brought on Thyra Eysselinck to talk about high-energy particles. Welcome to Curiosities of the Cosmos with Allyson Sheneman. My guest today is Thyra Eysselinck, a senior at SUNY New Paltz majoring in physics and astronomy. She is from Windhoek, Namibia, and currently takes part in planetarium show presentations and also high-energy astroparticle physics research. She is interested in cosmology and black holes. Thyra, thank you for being on the show today.
Thank you so much for having me, Allyson. It's a pleasure.
Of course. For our listeners, Thyra and I both started in astronomy at the same time and place in undergrad. We've worked a handful of jobs, been lab partners, went to conference and more together.
I believe it was an honors chemistry lab.
Yeah, and physics seminar.
We did meet in physics seminar. This is true.
A little bit of both.
A little bit of both.
So I'm just really excited to have her on the show today. So again, thank you for coming on.
Thank you so much for having me. I'm so excited.
Of course. It'll be fun. We'll talk all kinds of astronomy, astrophysics.
We'll get spacey
things.
with it.
Yeah, for sure. So first, just to kind of open up the conversation, I wanted to talk to you about like astronomy and like dark skies. So we've talked before about like how you've in growing up in Namibia and also like traveling a lot, have really had a chance to see how night skies change in different places and how important it really is to have access to dark skies. And just if you could.
Absolutely, yeah. So for anyone who doesn't know where Namibia is, it's located just above South Africa. And and if you didn't know this before, that is completely normal and irregular, which is why I feel the need to say it. But the beautiful thing about Namibia is we actually have some of the clearest skies in the world. We are a very underdeveloped third world country, but because of that, we have the blessing of lack of a lot of buildings and infrastructure that causes light pollution. And the main cause is just not well thought out street plans and stuff like that of light pollution, right? It's building lights that don't face to the ground. They face up at the night sky and get refracted in our atmosphere and stuff like that. So because Namibia has such a small infrastructure, we're really blessed with beautifully dark skies. And on top of that, we also have, it's a desert country. It's the oldest, has the oldest desert in the world, which is pretty cool.
Awesome.
But because it's a desert country, the atmosphere is so incredibly dry and dense, which again causes less refracting of the lights and just makes everything a lot more crisp and clear.
Yeah, that's awesome. And I think, especially now being in New York and doing observatories, doing planetariums, things like that, that when we go out to the observatory trying to collect data and things, it gets really difficult having so much light pollution, even being this far from New York City, about an hour and a half north, to still have that kind of light pollution. It's
astonishing. Yeah. Like I was made aware of what privilege I had growing up, being able to look up at the stars and actually see them. I've had some friends from like Long Island in the city who I take stargazing, and they're like, I didn't know there was this many of them,
right?
Which is insane to me. In New Paltz, New York, we're about, 2 hours away from the city, an hour and a half.
Something like that, yeah.
You can see what direction of the sky the city is in just by you can see the luminous, effervescence of the city trailing in the sky if you stand on top of a mountain and look up at night or out at night, which is terrifying.
Yeah, no, it's really scary.
Because, astronomy is the oldest science.
Yeah.
Humans are intrinsically very connected to the stars in many different ways. We base a lot of our beliefs, a lot of our culture around the stars. Yeah. And so to have created a world that we're so disconnected from them is, I don't know, it gives weird vibes.
Yeah, I feel like, I don't remember who said it, but I've heard this said before, that if we were to look up at the night sky more often, we'd be a lot different as a society and population as a world. I think there's really something that speaks to the connectedness of humanity and how we all, despite our differences, are so similar when we look to the stars, because it shows us how different we really could be if we were somewhere completely different. And so sharing this little precious thing together, and I feel like being able to look at the stars really helps us remember those kinds of lessons.
And kind of unify. I think
Absolutely.
about that a lot. Like Allyson and I, as I'm sure your viewers know, we do planetarium shows, and a big portion of a lot of planetarium shows is kind of just showing the cross-cultural relevance of stars and how different civilizations throughout time were able to look at the same things and imagine up the most beautiful creative differences, but some of them were really similar as well.
Absolutely.
Like, to be able to connect the dots in the same way and still see something different is really beautiful. And the different like parables that we've told through our stories and in our skies are gorgeous. And I really wish that was more of an emphasis, especially for tourism. We've talked before about like star tourism and how I wish that would be more of a forefront in travel, because I feel like learning how a culture interpreted the sky is one of the best ways to really understand the basis and the roots of that culture's, essence.
Totally.
Right?
Yeah.
And so I wish that was more of a thing instead of just looking like even at museums and stuff.
Yeah.
Yeah.
Yeah, for sure. And I think like both of us have traveled a little bit at least.
Yeah.
But I feel like in my traveling experiences, never was it a part of the itinerary to spend a night where we're looking at the stars together. And I think that it's kind of sad to me that it's only in having pursued astronomy as a major and having been hired at the planetarium to work there to present the shows that I've really gotten a sense of how much the night sky changes when you go to different places, and not just whether the sky has light pollution or not light pollution, but also being in different hemispheres, how the constellations change, and the idea that like there are certain stars that never set for certain people, and how like if you go to the North Pole, all of the stars never set really. Like those kinds of things were just so mind-blowing to me that I would have never been able to guess on my own, that I feel like prior to like this era, when people were more connected to the stars and did get to look at them more, you would be more aware of those kinds of differences.
I also think it's a bit of a Western thing, because I've definitely been to countries where there is so much more emphasis on the stars.
Yeah.
For example, in my home country, Namibia.
Yeah.
If you go to any safari at all, they will take you on a night drive where you go out and see the nocturnal animals like the porcupines and stuff. But a big part of that will be going to like again, it's a desert country, so there's a lot of like riverbeds of just sand, and you drive out into the middle of a riverbed and they turn off all the truck lights and you're miles and miles away from the closest farmstead, and you just look up. And sometimes they'll do exercises where you just they'll have everyone stand in a line and walk forward looking straight up, and you walk straight into just pitch black, but you're in a riverbed, so you're just walking on sand. You're not going to run into anything. But it's such a beautiful exercise of just trusting the world and being connected to something so vast and great, and fully giving yourself into that and allowing yourself to, take part in this bigger sphere of knowledge that we can't really even comprehend.
Totally.
It's completely beautiful. And I know in Chile they do similar things too. Sky tourism is more of a thing there as well. But it's, again, maybe it's just because in those places they have the privilege of having those those skies.
Yeah, I grew up in Michigan, and in 6th grade, I had the absolute privilege of going to a school called the Zoo School.
I'm so jealous
I
of
know,
Allyson
it
about
was
this.
incredible.
We've had really long talks about me. I'm just seething. Like, that's every kid's dream.
Yes. And it absolutely was my dream. It was everything that I could have ever imagined. And because I just happened to be a kid that lived near the school, like I just got to kind of go. And it was a school that started when my dad was in 6th grade. So my dad was like the second class to ever go. And
I
then
didn't know it was a legacy.
Sort of, I guess. You don't get in any, there's nothing special to it.
Grandfathered in or anything.
Yeah, exactly. I wish. But yeah, I as a part of that program, they kind of target bringing in high academic achieving inner city kids. So the whole point kind of is giving access to kids who might not otherwise get to see things like the night sky, who get to hang out outside, kind of get to spend a whole school day just outside and see how the kind of different learning styles that happen then. And so I'll never forget my camp experiences where we would just go outside, and it was my first time ever going camping. I never experienced anything like that before. And we had these nights where we would sleep under clear tarps, and I woke up in the middle of the night because my camping partner had stolen the blanket, and I was freezing cold because it's nighttime and you're outside, which I learned quickly.
No sun means cold.
Yeah, no sun means cold. And I remember looking up at the night sky and being astonished. And it was not that far from the city that I grew up in. It was just like northern Michigan. And I will never forget how much that like really meant to me as a kid. And I didn't know at the time that astronomy was the thing that I was going to do, but I knew in that moment that science was. And I feel like that's part of like making science more accessible is making the night sky more accessible too.
Oh, absolutely.
Yeah.
Absolutely, yeah.
Yeah.
That's such a beautiful story.
I know.
You had the whole entire like breadth of the universe exposed to you all at once in that.
Yeah.
And I feel like that's a common experience for people that finally, get the privilege to see the sky as it was naturally viewed all those years back.
And I think we see it a little bit, even though New Paltz does have light pollution, because it's not nearly as much as New York City, which, I mean, you can see like 3 stars total at night, that we still see people who come up from the city who are like,
just to look at our stars.
Yeah, what is this?
Yeah, now imagine if you were somewhere else in the world.
Yeah.
That's also a crazy thing, too, because I've moved quite a bit in my life, and the biggest adjustment was going from Namibia to America for the first time, because it's not only a difference in the quality of the night sky, but also the type of stars you're seeing.
Right.
I had never saw the Big Dipper in my whole life, and so when I moved as a kid to America and my grandma pointed it out to me, I was like, oh my gosh, that's what? And then like the Magellanic Clouds, and for people who don't know what the Magellanic Clouds are, in the southern hemisphere you can see these 2 fuzzy looking clouds in the night sky, and they almost look like if someone took the Milky Way and cut out circles and like placed them in the middle of pitch black sky. Yeah. That's what the Magellanic Clouds look like. And they're very hard to see unless you have very clear skies, but I always saw them. And so coming up and not seeing, our 2 little sister galaxies, for information about the Magellanic Clouds, they're dwarf galaxies that our Milky Way, our galaxy, is currently eating. We're currently slurping them up.
Galactic Cannibalism.
Galactic Cannibal. Great band name. But yeah, so those are all these type of things that I never, hadn't seen before coming to America, and vice versa. So 10 out of 10 recommend if you go to another place to look up.
Yeah, absolutely. We're going to get started with our first segment, actually. Woo! So our first segment of the show is called Should We Be More Worried About? And so sometimes in doing public science communication, as I'm sure you have experienced doing the planetarium as well,
Absolutely.
You get asked questions where people are already nervous before they come up to you about the answer. Like, oh my God, like I just learned about XYZ new thing, and I'm feeling like, why is nobody talking about how scary that is, right?
I think in astronomy especially, like we're in a really scary field, like just for our species. Yeah. And it's because when you really start to like acknowledge, because you know about it, but you don't really think about it, the breadth of the universe, you realize just how infinitesimal you are and just how meaningless. Not to sound like, existential, but it's true. Yeah. And I think astronomers are a special breed of people who find comfort in that. Totally. That infinitesimality, I guess. It's beautiful to be so small and comprehend such huge things. Yeah, totally. But with that being said, most people see that and see absolute fear. Yeah. And they see just an endless list of possibilities of how things can go wrong. And they're not wrong. Like, there's a lot of factors leading into us not existing, and somehow we are. Yeah. And totally. Allyson and I took a, what was it? Life in the Universe class. Oh, yes. Yeah, where we learned about just how improbable life is, or how probable it is. Yeah. Turns out optimism actually plays a factor in your estimations. Yeah, totally. But anyway, back to the question at hand. Yeah. Which was. Yeah. So we're going to talk about things that we maybe should or maybe shouldn't be more worried about. Right. And so my question for you is, should we be more worried about the sun dying? The sun dying. Yeah. Okay, well, just to cut the suspense. No. Yeah. No, we don't really need to be worried about the sun dying in our lifetimes. In fact, I believe the sun is going to continue burning helium into hydrogen for like another 5 billion years.
Hydrogen into helium?
I meant helium into hydrogen. Thank you so
First
much.
one.
Yeah,
The hydrogen into helium.
hydrogen into helium.
Yeah.
That's what I meant to say. Thank you.
That's all right.
They both start, okay.
They
for
both start with
preface,
H's.
To the audience, I make a lot of silly mistakes when it comes to words that start with the same letter. I'm dyslexic. Tuesday and Thursday are the same day,
I would agree with that.
right?
Yeah.
And so, and they have
And
similar
Saturday
vibes.
and Sunday?
They're the same day.
Yeah, it's all
They
the
have
same.
different vibes, though.
Totally.
Absolutely.
Yeah.
But anyway,
And so do hydrogen and helium.
the point being that that's only going to happen in about like 5 billion years.
Yeah.
And then on top of that, the sun will eventually then go to burning, I guess, helium into carbon.
And a load of other things.
I think we're only going to get up to carbon with the mass of the sun,
Yeah.
right?
But it's not just carbon.
Well, yeah, you're right.
Yeah.
But so, and that's going to be another like 2 billion years.
Yeah.
So we got like 7 billion years to kill,
Yeah.
which is a lot of time. And I know some of you guys are health gurus out there, but I don't think you're going to reach 7 billion.
Probably not.
Probably not. And on top of that, before that even happens, because how stars die is at the end of their life when they stop burning one fuel source into another. Clearly, I can't remember what is what. They start to expand and grow really big. And so our sun, during its long, drawn-out death process, is going to engulf Mars.
Yeah.
No,
Mercury.
Mercury. Starts with an M, folks.
Starts
Do you
with
see
an
what I mean? It's going to engulf Mercury and Venus, and maybe even Earth.
Yeah.
So even before our star dies, we might be toast.
Yeah.
But again, that's like in 5 billion years.
Yeah, totally.
Not a problem.
I feel like, too, people forget sometimes, like, because I feel like some people might hear, oh, it's happening in 5 billion years. Sure. But I might not personally be around, but wouldn't my, like, great, infinitely great,
something,
yeah, grandkids be around? I think people forget just how little time we've been here so
Yeah.
far that, I mean,
I wish I had a statistic on how long the human race has been going on.
yeah, well, it's something,
Yeah.
it's something like, if I'm remembering correctly, Carl Sagan has that good bit about, like, the turning the universe time scale into a calendar.
Yes.
And it's like the last, like, teeny tiny fraction of a second that
We've been
we've
kicking.
been here in the way that we're here now.
Yeah.
And so it's definitely, I mean, it's in the small, like,
Yeah.
tens of thousands, if you're optimistic, hundreds of thousands of years for us. Yeah, it's not that.
Absolutely.
It's not 5 billion.
No, it's not 5 billion, and we've done so much in those years. Imagine if we were, as a society, as a species, to survive that long, how just fine we would be. Think about 5 billion years of innovation and scientific evolution. I think we'll be okay.
Yeah, I mean, if
we manage to survive the things we're doing to our planet at present. I don't know if the sun's more of a problem or if it's us.
Yeah, I think for sure if we're picking something to be worried about and to focus on, maybe our own backyard a little first. Right?
Yeah, no, for real. Honestly, I was looking into this. I feel like solar flares, if we're going to worry about the sun, are a bigger issue.
Yeah.
And I didn't know they were as big of an issue as they actually are. I thought they were a bit dramatized because I've seen movies, where a solar flare goes off and the entirety of humanity is stripped from all telecommunications and the internet shuts down and all power sources are gone.
Right.
But like solar flares, actually kind of scary. They mess with the
yeah.
magnetic field of our Earth.
Yeah.
The last one that was really big was like in 1850. So they don't happen very frequently, and it didn't do too much back then, but it was also 1850.
Yeah.
So we didn't have that many,
Telecommunications.
happening.
Right.
But yeah, there's a serious potential that a solar flare could completely wipe out all of our GPS systems, all of our telecommunications. Power would be lost to many major cities for like several weeks. It would be like a complete, like, we'd be cut off and put in the dark for 2 days. And so there's actually like a lot of funding going towards like detecting solar flares because there's nothing we can really do about it besides prepare.
Right.
Which is terrifying. Not that you should be scared. Okay, let me preface this also by saying they're very unlikely to actually hit Earth because we're so small. So it would have to be very precise, very unlucky ratios of, a flare.
Yeah.
But that is the thing.
Yeah. There's definitely bigger things to be worried about than things happening in a couple billion years.
100%.
Yeah, things to put more funding into. I hate to interrupt this wonderful conversation, but we're going to take a short break, and we will be right back in a couple of minutes. Welcome back to WFNP 88.7 The Edge, Rosendale. This is continuing with Curiosities of the Cosmos. I'm your host, Allyson Sheneman, and I am joined by Thyra, a senior and student of astronomy and physics at SUNY New Paltz.
Hi.
Welcome back.
Thank you.
We just had a great conversation about dark skies and the death of the sun, but in a not scary way. And we're going to continue now with some more on astrophysics. So could you summarize your research, the research that you've done, in a way that like somebody who's like 5 years old could understand?
So I feel like this is a terrible thing to ask me because my research is very jargon heavy.
Yeah.
There's a lot of just reading the brief description that my advisor initially sent me for my research. I had to make a whole thing called an idiot index, which was just all the buzzwords that they used that I had no idea the context or meaning behind them. Totally. So let me say the big kid version of it. I studied cosmic ray anisotropy. Mm-hmm. Whoa. Yeah. So let's start with cosmic rays. So cosmic rays are actually just really high energy particles zooming through space at the speed of light, or almost the speed of light. Not at it, but very close. Well, close for particles.
Right.
And what these fast-moving particles do is once they come into contact with our atmosphere, they interact with it, and it causes this cascade effect. It rains down a shower of different particles onto our Earth. And then we detect these particles through a lot of really cool mechanisms. So I was working with IceCube, which is a neutrino observatory in the South Pole. And a neutrino is, again, a type of particle. High energy particle. And so they've managed to do something incredible. They utilized the really clean, beautiful ice in the South Pole to turn a huge chunk of ice into a trap for these high energy particles. Because when these high energy particles go through a different medium, so again, they don't move faster than light in a vacuum, but when they move through water or ice, they are moving faster than light would move through that water or ice. Right. And that's really cool because it causes this effect called the Cherenkov effect, or Cherenkov radiation. And Cherenkov radiation is essentially when a particle is moving faster than light would in that medium, it sends off this beautiful beam of blue radiation. And that's what our detectors embedded in the ice see.
That's awesome.
And measure. I know. It's so many steps. People are smart, hey. Sometimes I think of wow, you guys you thought of that. Yeah. You connected all the puzzle pieces and you got it.
And now we're here.
Yeah. So I was measuring these particles that, get detected. Now, normally we look for a neutrino, which is really the star of particles currently, and everyone's looking for the neutrinos because they're super high energy, but an off product of these cosmic rays are these things called muons. And a muon is similar to an electron, which is one of, another type of particle. Yeah. But it's really heavy and it dies really quickly. So I'm looking at these muons, and the reason I'm looking at them is because they're so plentiful. There's so many muons given off by all these cosmic rays once they break down and scatter in the atmosphere. And so that makes them really statistically significant because we have so many of them. Yeah. And so if we count and redraw where all these muons are coming in and hitting the Earth, because we're able to do that with IceCube, the way the detector is set up, we're able to see where these incoming cosmic rays are coming from. We can see kind of where the distribution of cosmic rays hitting Earth are, and if there's any more on one side or the other. And anisotropy kind of means an excess on one side and a deficit on the other, or distribution. And so that's kind of what we were looking at. And the reason that's significant is because we don't know where cosmic rays come from, which is super terrifying. Yeah. I've just talked so much about them because we know they exist. We're absolutely certain they exist, and we've done a lot of things with them, but we don't know where they come from. We just know that there's some high energy process that creates them. But because they're charged particles, the magnetic fields, the ambient magnetic fields in space, cause them to deflect as they travel through space. So we can't just like,
Trace it back.
Draw a line back up to where it came from, because it's a random motion until it hits Earth. So yeah, they're
Complicated. Very.
Yeah, I don't know if a 5-year-old would have gotten that. But basically, I looked at the muons and I saw where they were hitting Earth, and I noticed that because it's randomized, their path towards Earth, the cosmic ray's path towards Earth is randomized. It should be completely linear or uniform. It should hit Earth around the same percent all around at all times, but it's not. We do have a dipole, which means that there's an excess on one side of the Earth and a deficit on the other, and we use different mechanisms to simulate why that could be happening, essentially.
Awesome.
It's pretty cool.
It's cool stuff.
It's pretty cool.
So I guess one of the hypotheses for why that might be happening is because of the Earth orbiting around the sun, right?
Yes. It's called the Compton-Getting effect, and this I can explain to a 5-year-old. It's essentially the same thing that happens when you're driving through the rain. The front windshield of your car will get hit with more rain than the back windshield. And that's what's happening to our Earth as it orbits the sun, is the front of our Earth that's facing the direction of motion is getting plopped and hit with more cosmic rays and muons than the rest. And the reason it's good to really understand how much extra we should be getting hit with these cosmic rays and stuff is because that's not the only anisotropy we see. And so if we're really able to diagnose the anisotropy we can predict, the excess anisotropy that we can't really explain yet will become a lot clearer, because we can actually just solely view it instead of,
It's awesome.
Thank you.
I love the like windshield explanation.
It's a really good one. My advisor
so
told me that, and everything made sense. I was like, oh.
Yeah, once you get it, you get it.
Yeah,
yeah,
it just makes
awesome.
sense. I love science.
Awesome.
No, it's beautiful when you can create an analogy like that where it just clicks, and you see on people's faces like it becoming a thing that's actually feasible.
Yeah,
that's so beautiful.
Yeah,
I envy teachers for their like actual job description is to create that all the time. Like, it's hard.
Yeah,
I wouldn't be able to do it, but wow, to get to see those moments
makes it worth it.
Oh yeah, I'm sure.
Totally. I think kind of piggybacking off of that, I think if our our listeners haven't kind of gotten the gist already, you're a very extroverted person.
Oh yeah.
And I think you have a lot of like ambition for explaining things to people and making sure that like the science that you're doing isn't just cool science, but that it's cool science that other people can understand and be interested in. And I think that like that's something I relate to a lot, and I think why we get along so well, at least in part. And so I guess I'm curious what your experience has been like as an extrovert in a field that is so stereotypically introverted.
Yeah, I think we were talking about this earlier, but in its essence, science is collaborative. It's meant to be done with people. You're meant to put the best of your brains together to create something bigger and more beautiful about something that's bigger and more beautiful than you are individually. Not to say you're not beautiful, Allyson. You are stunning.
Thank you.
But yeah, so I often get hit with weird looks when I tell people I'm in science, because I do come off as a very like, hi, I'm in your face and I want to hang out and let's talk about things. And people are like, how do you spend so much time alone studying? And honestly, if it wasn't for like my peers, I wouldn't understand half the things I understand.
Totally.
So much of my getting through classes was sitting down at a table with people who were equally confused, and we put together each bit that everyone else got that the other person didn't until the puzzle was complete.
Totally.
And I think, I mean, it sucks if you are introverted because there's so much that can be grasped and caught with the aid of others. So I love being an extrovert in science, and I think a lot of scientists, especially in terms of like creating and consolidating knowledge, are extroverted. Even if you're an introvert socially, I feel like I know a lot of people who like don't hang out, but when it's time to talk physics, they like creep out of the woodworks and they're like, I'm here.
Yeah. Well, I think it's easier for people to like find that community sometimes too, because there's this stereotype that everybody's introverted, and so maybe it's a little less intimidating for people who are otherwise kind of on the quieter side to kind of like join in to those conversations, I guess.
Oh, yeah. We have a pretty amazing group of physicists, or of our generation of physicists at New Paltz currently, which is the school we go to, by the way.
Yes.
And it's beautiful to see all these very, very different people come together. Like, I wouldn't be friends with half the people I am currently friends with. But because they're in physics, we have this shared commonality
Yeah.
where we're able to come together over this. And I'm so grateful because those perspectives are invaluable to me.
Yeah. Yeah, and I think especially as we go into, because we're both seniors, both graduating. Yeah, scary stuff. And also extremely exciting that I think as we go into those fields and as we both kind of just got out of kind of bigger research projects and being in kind of immersed into what our futures look like, that it's becoming more evident that that collaboration and that collaborative aspect, it doesn't just not go away, it amplifies. And the further you get into science, the more important it becomes to be able to collaborate with people, to understand the benefit of a perspective that's different from yours, and to consider what somebody else might have an idea about in terms of your research, in terms of a certain subject, especially as we're getting into higher level and harder classes, being able to like have those conversations. I think it's just, it only gets more important.
Oh, absolutely. Like having the gift of like perspective and empathy is so incredibly important just for humans in general. Like if we just look at our like basic, I don't know anything about biology, especially compared to Allyson, but human beings as creatures are social.
Yeah.
And that's why we've created a social world. And so I think it's really funny how prevalent a Western ideology of the individual prevails in our minds, and how we approach the world, and how we're taught as Americans or as, you know, people who live in the West how to approach the world.
Yeah.
Because it's an individual approach set to a social scheme.
Wow. Yeah.
And so, oh my gosh, I got a wow.
No, that makes total sense.
And so I think it's really unfortunate, and I think we could learn so much more if we, you know, took more time to learn from Eastern cultures whose entire, you know, it's for the collective.
Yeah.
And we are a collective. And as much as we want to deny that in science, in politics, in, you know, everything, we are a collective. And you need to have the skills to work with your collective, or else you won't really get anywhere.
Totally. And I think a part of that I think both of us kind of like dream to do and hope to achieve at least somewhat. I mean, it's a kind of big goal to just be like, I'm going to achieve it in my lifetime. But just like that, I think both of us kind of aim to chip away at the division that's present for science as a community as opposed to the rest of the collective.
Yeah.
And so I think that as it stands now, I think we probably both noticed that science is kind of considered this like separate thing. It's this thing that's only for people who are hardwired to get it or not get it.
Yeah.
And that it's like elitist, or it's meant for one type of person or something like that. And really, I think both of our goals probably is to make it a little less so that.
Yeah, no, I hate that science has been blocked off for a certain sect of the public. And I was talking about this during my REU because I am historically really rubbish at computers.
And for people who don't know, an REU is...
Oh, yes. It's, okay, acronyms. REU stands for Research
Experience
for undergrads. Thank you so much, Allyson. But yeah, so that was the summer research I did. And when I was there, I was learning a lot about coding. And I was so incredibly frustrated the entire time because coding is just completely entrenched in jargon.
Yes.
Words that don't need to be there, that have very simple, like self-explanatory meanings if you just used a normal English word for it.
Right.
And I was talking to some grad students about it, and I was like, why is it called that when it could be called this? Why is it broken up in this way? Why am I so confused? And they looked at me and they said, without, you know, batting an eye, it's to confuse you. And I went, what? And they were like, yeah, it's to specialize this field so that the layman can't do it.
Yeah.
So that we stay important. We stay...
Wow.
And that's so unfortunate.
That's
and
really
I feel
sad.
like that like elitist segregation of knowledge in language is such a prevalent thing, and especially in science. Like, again, my research, it's about fast-moving particles and where they end up.
Yeah.
Oh, I could have just said that. But instead I say cosmic ray and isotropy. Like, whoa, you know?
Yeah. And I think that it's good to be able to translate those two things, right? So to be able to say both of those.
Yeah.
That I think to certain audiences, cosmic ray and isotropy is something that immediately clicks and it makes sense in
Right.
the same way that fast-moving particles and where they end up clicks to most people and makes sense.
Yeah.
But I think being able to, I guess, turn complicated things into a way that like anybody could listen to it once and have it make sense.
Incredible skill.
And so sadly absent, I feel, in a lot of science right now.
100%.
Yeah.
100%. Which is why people like Neil deGrasse Tyson and like the science guy. What's his name? Neil. His name's
Bill
also
Nye.
Bill Nye. Who's the other Neil? There's another Neil. It's okay.
Neil Armstrong? Like he's a science guy, I guess.
He's a science guy, I guess.
In the way that all astronauts
Or
have
science,
to be, I guess.
Science people. But yeah, people like that, that's why they're such a gift
Totally.
to like children everywhere.
Yeah. Yeah. I think always good to start young, right, with those kinds of things to be able to make science accessible. I think that's why so many people hold on to people, especially like Bill Nye, where his whole purpose really was to make science something that was fun and exciting for kids.
And you and I were really gifted and privileged in the fact that you went to a zoo school.
Right.
In elementary school, when I did live I lived in Minnesota for a second. But when I did live there, I attended a science magnet school.
Wow.
Which was the most incredible thing. And I remember going from my science magnet school back to Namibia and feeling like I had this wealth of knowledge and like keen understanding of the environment and what really is important in terms of like conserving nature that my peers didn't.
Yeah.
And it's because I had the privilege of having a school where our backyard was the entire back of the school was like a reserve. Yeah. And we could go cross-country skiing, which is crazy. It was a public school in the winter, and we had to spend days outside learning to identify different plants and animals and learning about pollution and how important conservation is and stuff like that. And I'm sure working with animals, you too.
Yeah, totally. I mean, we had the zoo itself where we would just like take a math class and there would be a whiteboard and right next to us are just like monkeys and stuff. It was awesome. But also having the like land that the zoo was on as our backyard, we had quiet spots in the forest, which I highly recommend if anybody is interested in that. We just had our own like assigned spots that we picked that were our quiet spots, and when we were out there, we couldn't do anything else. We just had to sit there in silence.
That's so beautiful
to
teach at a young age, that connection to nature.
Totally.
Which is so scarily, I guess, absent.
Yeah.
I don't have a kid. I'm a 23-year-old woman. I don't know anything about bearing children. But I do know that my little cousins, with them, I can see the prevalence of like iPads and phones
Especially
and social
COVID,
media and stuff.
babies.
Especially during COVID. I mean, you couldn't go outside.
Totally.
So like the fact that was part of our education system was so beautiful, and I really hope that's, kept up.
Totally.
I haven't been to kindergarten in a hot minute, but
Yeah.
I hope they're still doing that.
Totally. And I think like a part of it too is like the school that I went to was just a 6th grade. And so all of my schooling before and after that was very like typical, and they're all public schools that I went to, so it was very typical, just like regular public school stuff before and after that. And so there's just a part of me that's like why not more? Like what is it that also like for people to have had to test academically to get in, right? Like there's just a part of that like so like rubs me the wrong way, that just like,
how come the gift of enjoying and being one with the universe and nature is reserved for those who academically have the resources to get in?
Yeah. And so I think like to me it's like why isn't every 6th grade go outside like sit in the woods and write in a journal? Like why doesn't every 6th grade go camping? Like and so it's sad to me that I guess, I mean, a part of it, obviously, is that the resources aren't there for every school. But, I mean, couldn't they be?
I don't know. It's like we were talking about earlier about, like, what really should we be worried about?
Yeah.
And the environment's a huge thing. So you would hope that if we're not going to do anything about it in our generation, we'd at least educate the next one who has to deal with it,
Yeah, there's a lot of that passing down the responsibility.
abilities, yeah, but not
Yeah.
giving them the resources to handle it.
Totally. So, to kind of brighten up what could be a kind of sad topic there, we're going to cut to our next segment, which is Curiosity Corner.
Ooh.
Yeah. So this is where I get to tell you some fun facts, and you get to rate how mind-blowing they are
Okay.
on a scale of 0 to 10, where 0 means that it's not fun or you didn't learn anything, like you already knew it.
Hit.
Yeah, it didn't hit. And 10 means that you're going to think about it every day for the rest of your life, whether you like that or not.
Oh gosh. I feel like this is an incredibly subjective thing and says so much more about me than it does about the facts.
Totally. But the facts are still facts,
This is true.
and the rating is subjective. So it's a little bit of both.
It's a little bit of both.
A little bit of both. So
Little humanity.
our first fun fact, these are hand selected for you specifically.
By yours truly.
So I have a feeling you're going to like them.
Oh, I'm excited.
The first fun fact is, you don't like the sound of your own voice, at least in part because of the bones in your head.
Okay.
So, to elaborate a little.
Wait, can I make a guess?
Yeah, go for it.
Is it because when you speak, during the process of speaking, the sound waves, cause a bit of rattling and the bones jiggle a little? And so when you are speaking and you hear your own voice, it's accompanied by a jiggle that makes everything just a little bit off.
I'm going to be honest with you. I think kind of. I think that is kind of the answer.
Dude, I'm so smart.
So,
what?
It's not for sure. I mean, it's a hypothesis that people have that it's because of the bones in your head. But the reason is because when you speak, you hear your voice both through like the air conducted sound, which is just what everybody else would hear for you, and also through bone conducted sound that goes straight from vibrations in your skull to your inner ear.
Oh
So
my
you
gosh,
hear a little
I
bit of
was
yourself,
right.
and also
But you also feel it a little too.
totally. So it's because of those vibrations, the vibrations that are sound, that it goes both through your own skull into your ears and also through the air into your ears. And when it travels through the bones and through your own skull to get to your inner ear, it deepens the tone, whereas the sound that comes out just into the air is less deep then. And so when you hear a recording of your own voice, you're not hearing the part that's transmitted through the bone into your
my
ear.
My voice is so deep and alluring and beautiful, and everyone else is hearing a chipmunk. No
Potentially.
wonder.
But I think that's maybe why, at least in part, it doesn't like ring true when you hear a recording of yourself, because you're like,
Where's the
that's
bone
not me.
shaking?
Yeah,
noise?
where's the deeper
Where's the jiggle
inner
jiggle?
ear vibration, right? So,
Oh my gosh. Well,
cool stuff.
I will say, and this has maybe nothing to do with what you said, but it made me think about it.
cool.
Elephants,
Yeah.
they communicate, and we always thought they communicate, through their trunk and the or whatever. I'm so sorry. That
Yes,
was bad.
I know this.
But they actually communicate through vibrations
stomping.
in the ground, and they stomp.
Yes.
Oh gosh, sorry. They stomp, and they can feel. That's why their feet are so big. Well, they're also
Yeah.
big because they're elephants.
Yeah.
But they're also really sensitive foot pads. They have really sensitive foot pads, so they can feel individual little vibrations
Yeah.
and understand it.
Isn't that so cool?
That's crazy. So
They probably don't hate the sound of that.
no, they probably love the sound of their
Yeah.
voices. But like I'm saying, maybe it's a similar thing where we recognize our own
Yeah.
specific vibrations
That's so interesting.
in our heads. Maybe. Yeah.
Maybe.
That was a cool fact.
It's pretty
Allison.
cool,
This
right?
is just
So now
pretty
you
good.
have to give it a rating.
Okay. Let me think.
0 to
Um,
10.
I don't want to be rude.
It's okay. I've
to
had
this
I've had
fact.
0s and 10s before on
You
the
have.
show.
I'm
Yeah.
sure you have. Allison gives range, everyone. I think I'm gonna give it like a good 6. Is my favorite number.
That's my birthday.
Really?
August 6th.
Mine's
Yeah.
9th.
That feels like
Yeah.
it's like kind of the same.
It's the same number.
in the
it's
same way
just
that
upside
Tuesday
down.
and Thursday are the same.
Yeah,
Yeah.
but also like looking
Yeah.
because it's a 9 and a 6.
Yeah.
Yeah, I think I'm gonna give it a 6. That was really
Awesome.
cool. But because I was so quickly to identify why, because I'm a genius, I'm not that impressed.
Understood. I'll do
Yeah.
better next time.
Do better. I really want to know why you handpicked these for me.
Only time will tell.
Only time will tell.
You'll have to figure that one out yourself too.
Okay, another
since
one.
you're a genius, you'll figure it out. This one you will immediately know why I picked for you.
Probably okay.
So, well, maybe not. I have to clarify a little first before you'll know.
I get really insulted. I start crying.
So the largest.
The largest.
Largest.
It's my favorite book.
What? Okay, understood. The largest organism by mass isn't a blue whale. It's a forest of over 40,000 aspen trees in Utah that has one shared root system.
Oh.
Isn't that awesome?
Isn't aspen where rich people go to ski?
It's a type of tree. I mean, it might also be that.
I think it's also a place where rich people go to ski.
I don't know. I'm not a rich person, so
Yeah.
I'll have to ask them.
Oh my gosh, that's insane.
It's called Pando, like panda, but with an O.
That's great.
And it spans over 100 acres. But the largest organism by distance covered is actually a honey fungus type of mushroom.
We love
that
fungus in this house.
2,200 acres.
I was gonna say, I thought it was because like mushrooms connect an entire forests with their like system of mycelium. Thank you.
It's the little like.
It's like roots, but not really.
Yeah, kind of like hair.
Yeah.
Yeah.
Oh my gosh, that's insane. So all these trees are connected, like their roots have fused over time, or it was one tree and its root system just kept going.
So what I think it is that it's like I'm guessing here, but I think it's probably that it's the type of organism that can like sprout other versions of itself from the same one root system. So what I'm assuming in order to qualify as one organism, it's probably not separate ones that then interconnected.
Fused.
I'm assuming that it would be.
There was just one aspen that was
that
like
just kept
it
growing.
was the little aspen that could.
It was.
That's
and
beautiful.
it could 40,000 times.
40,000.
Yeah.
Wow.
Yeah.
Dang. You know, I don't know why I'm thinking of this, and I really shouldn't continue on this brain tangent. Please cut me off.
Okay.
But I'm thinking about how during the wartime, they had to. I know. I'm crazy like that. During the wartime, women were given awards for having a bunch of kids.
Yeah.
And if
so
you had,
true.
and so you were given medals and stuff. The church would give you medals, and there was this. I lived in Minnesota, as I've mentioned. Yeah. There's this old church where this woman was given that medal twice. You got a medal for having 12 kids, and she had it twice. She had 24 children.
No.
And I bet her name was Aspen.
Yeah. That's still nothing compared to 40,000.
I know, but she's doing her best, Allyson. Jeez.
All right, 0 to 10. What are we thinking?
Oh, that's a 10 out of 10 fact.
I thought so.
It mentions mushrooms.
I knew you would get it immediately. I knew it.
We love foraging. We love mycology.
Yeah.
If I wasn't doing stars, I'd be doing mushrooms. Wait.
Well,
I'd be studying mushrooms in a non-hallucinogenic fashion.
All right. We got one more fun fact here. While other animals can have jaws, humans are the only animals with actual chins.
I don't know how I feel about that.
Yeah.
Let me let that sink in.
So I'll while you let it sink in, clarify a little more on that one. So the way that it differs between humans and other animals is in its prominence, its bone structure, and the muscle attachment. And it is thought to be linked to social reasons for like speech and facial expressions, to be able to like socially interact in more, I guess, variety than other animals can.
So my mom has a really pointy chin. And she always told me, shout out, thanks a lot. But she always told me that her chin was like called the aristocrat's chin, and it was a sign of nobility.
Interesting.
But also, now that I think about it, she always made fun of the British. Words of wisdom for their chins, because apparently they had very weak, soft chins because they were always eating boiled vegetables.
That's awesome.
And so their chins weakened because they didn't need to have the muscles and the strong structure because they were eating mush all the time, because British cuisine is mush.
So true.
So sorry to all the UK stands out there.
Yeah.
But what? A fox? I feel like foxes have chins.
No. They have like snouts.
They have snouts. That's so true.
Like
I guess that's the chin equivalent.
Yeah.
A snoot.
Yeah.
I don't like that.
Yeah.
I'm wildly uncomfortable.
See, I thought you were going to like it because, I mean, even in this episode alone, we've talked about how, like, humans are social and
Yeah.
need that kind of, like, interaction.
Oh,
and that's at least in part how we can do it.
That's so
we
true. I
think.
was also going to talk about how the mycelium and the one tree happens to encompass everything we've talked about as a collaboration, you know,
Yeah.
coming together and stuff. And then I completely dropped it because you told me monkeys don't have chins.
No, they don't.
Are you sure? Like a
Some of them-
chimpanzee?
So
Can I Google a chimpanzee?
you can do whatever you want to do. So in my research into this, it seems that, like, some animals have resembling chin structures, but they just don't have chins.
They
But
don't have that bone that
you would be
sticks out.
shocked at how difficult, apparently, though I had no idea that this was the case, how difficult it must be to identify what technically counts as a
A
chin.
chin.
Because when I was looking it up, originally I just saw somewhere where it was like humans are the only ones with chins, and I was like, that's cool, I guess. And then I was like, I'm gonna actually look into all of these facts before I say any of them
What's
on
a
a
chin?
show. And apparently some people disagree with that because they think that there are things that we don't currently count as chins that should be.
What is the operant definition of a chin?
Yeah. I mean,
I
it's
wonder.
like a protrusion from your jaw. Like, I think it's
a
like
structurally bone-like intended protrusion.
Yeah, and the reason that it is that way for humans is because it's got that kind of, like, prominence.
yeah, it's an
that's, like,
extra
different
bone that's
from-
not really there.
Yeah.
But what I want to know is what emotion am I better able to express with my chin? Is it pouting? Is it something for the lips to fold over?
I was about to say, it must be something to do. I mean, but also, like, there are plenty of other animals that can pout. I think it's just for variety of facial expressions. Like, we probably have access to more types of faces to make where there's more subtlety between expressions that we can pick up on.
We do have like way more muscles in our face, I think,
Yeah.
than other animals.
So it might be from the same thing.
Yeah. That's so interesting.
Yeah. What are you thinking?
Just because it disturbed me so much, 10 out of 10.
Awesome. Yes.
10 out of 10.
2
I
tens.
hated that.
You're welcome, I think.
I'm an astronomer. I like to be uncomfortable.
Yeah. All right. So we're, with that, going to take a short break. So stay tuned, and we will be right back. Welcome back to WFNP 88.7 The Edge, Rosendale. This is continuing with Curiosities of the Cosmos. I'm your host, Allyson Sheneman, and I'm joined by Thyra, a senior and student of astronomy and physics at SUNY New Paltz. For our last few minutes and to end every episode, I ask the guests to bring in their favorite question that they've ever been asked. So, Thyra, what is your favorite question?
The question that you just asked me made me rack my brain for so long. And I think my favorite question I've been asked is, and this seems really narcissistic, but it's, why do you do physics?
Okay.
And honestly, it might not be my favorite, but it's the one I thought of.
Sure.
So we're going to run
It's
with
a
it.
favorite. It's
Yeah.
up there.
And the reason I chose that is because it's such a personal question. It essentially entails, like, why have you chosen this to be your, like, lifelong passion? Why have you devoted countless hours to learning about why our planet is the way it is?
Right.
But it's said in such a casual setting usually that it kind of invokes a, like, oh, because I like it response, you know? And it's impossible to get into, and I think we talked about this earlier, to get into, like, to try to explain to someone, like, oh, I think you said it runs in my blood, like it is.
Right.
Yeah, like, how do I just, like, go from, like, la la la, my favorite color is, to, oh, this is the entirety of what I want to be, and it invokes the fire within my soul.
Right.
So I usually end up just saying something funny. I usually go, oh, it's because I'm a masochist. And that's kind of true, honestly.
At least in part, right?
At least in part. I mean, physics is a hard field.
Yeah.
And so there's a little part of me that did it just to do it. And just just because it's hard.
Yeah.
Just to get that reaction. Like, I'm a little blonde girly, and I'm loud, and I can be quite obnoxious, and I make silly sounds. And so to go from that to, like, I do astrophysics is, like, I love that response.
Yeah.
And I'm sure you get that, too, as a female in astronomy.
Totally.
Or not astronomy. If you say astronomy, people don't take you as seriously as if they say astrophysics, which is terrible.
Yeah. But I mean, in any science, really. I mean, I get it for bio too. Like, it's kind of the whole situation, I guess. It's just that, like, when people don't expect that you were the kind of person, just at like first glance, to have been able to accomplish a thing that they think maybe that they couldn't do, or that is something that sounds hard to do. To be able to be the kind of person that's like, actually, you might not expect this of me, but I did this really hard thing.
I did this really hard thing, and I'm kind of good at it. This is the crazy thing. When I was in IGCSE, which is like international GCSEs, which is like British matric, which is like high school.
Understood. We got there.
It's the first 2 years of high school, essentially, and I graduated those because you do it in sections, and then you do the next 2 years, and that's a different diploma. I graduated with all A's, not to flex, and I was going the next year to pick up my books for my economics class, and it's a professor I had never had before, and he went, "Thyra," and I said, "Yes, sir," and he said, "I saw your results. Good job." And I said, "Thank you." And he said, "All this time I thought you were a ditzy blonde theater girl, and look at you got a head on your shoulders." And every response that I get from people is kind of angry, like, what the heck?
Yeah.
And I, in that moment, felt so, like, good.
Yeah.
Like, I know I should be offended that is the assumed thing of how people see me, but I love it.
Yeah, well, because it works in your favor.
It does. No one expects me to do these things. And so if I make a silly mistake, like call Tuesday, Thursday, or helium hydrogen, everyone's like, it's okay, she's blonde. And she's just a girl.
She's just a girl.
But then I drop, the word anisotropy out of my mouth. And they're like, oh my gosh.
She knows what she's talking about, too.
Kind of.
Yeah, totally. I think there's also a part of it, at least for me, that when I hear that, I really relate to the idea of like doing this thing because it's hard, and not just to say to other people, look, I might not be the kind of person, whatever it is, the image that you have in your mind that can do this thing, but I did it. But also for myself to be able to say like I just have this idea that like as I get older in my life, I don't want to look back at my life and be like, how come I never gave it a shot to try to learn about the universe? Like I get this short little like blip of existence and I didn't even try.
Exactly.
So there's a part of me that's like, how do I not give it a shot at least?
Absolutely.
Go as far as I can to understand as much as I can, right?
And there's so much knowledge in failing.
Totally.
Like I was talking to one professor at one point and he was like, this class is a safe environment for you to fail.
Love that.
Yeah, and I was like, that's so beautiful and so true because we're expected to succeed at all these things. But I love being in a profession where sometimes I go into class and I don't know a single word that's coming out of my professor's mouth. And I get so like flustered. And the greatest feeling is leaving that class and sitting down and going, okay, now I'm going to slowly figure it out.
Totally.
And it's okay if I don't.
Yeah.
Because it's safe. It's okay. Like, I'll figure it out eventually, and if I don't today, I will tomorrow. And it's okay if I don't then,
Yeah, and I think that's something that I think our education our education system, at least here in America, is not really set up to let us do.
No.
And I think that, like, I think that as like a human race, we know that failure is important in the learning process. And yet we made systems that make it so that failure prevents you from being able to do.
It discourages you from trying again.
Totally.
It's seen as a bad thing instead of an excuse to learn.
Yeah. And I think that especially maybe pertains to like how we see STEM and science, because science, you can't do science without failing. You just can't.
Truly.
Like it is so built into
it's
the
intrinsic,
field. Yeah, the process. You have to fail in order to do science.
It's part of the scientific method.
Yeah, totally. And even a success is a failure of something else.
Oh, absolutely. It kills another theory.
Exactly.
And I understand why, like, just thinking of that, I understand why there's so much competition in science and why it's seen as so cutthroat sometimes because of that. But it really shouldn't be, because at the end of the day, it's this, like, beautiful pursuit of knowledge, and that knowledge is everyone's.
That knowledge is everyone's. What a wonderful note to end off on. Sadly, that's all the time we had for today. So thank you again, Thyra, for coming on the show and for this insightful, funny, informative, kind of healing conversation.
I feel like I've been in therapy.
Yeah.
I feel good.
And of course, thank you all for listening. This has been your host, Allyson Sheneman, and my guest,
Thyra Eysselinck,
on Curiosities of the